Okay, so section 2.4, complex numbers and operations. We multiply these two. This is pretty cut and dry. You're going to use FOIL. And remember that if you ever see an I squared, you get rid of it because it's -1. So that -3 becomes +3. Combine the like terms, and by like terms, I mean the imaginary parts with the imaginary parts, reals with the reals. And your final answer should be 13 minus I. 5I minus 6I is -I. Excuse me, I'm getting sick. just like stuffy. All right, do the same thing. These guys look like conjugates, but they're not. All right, they're not, because that's a 2i, that's a -3i. And FOIL it out, and that -6i squared at the end is going to become a +6. Those actually cancel out, so you're going to end up with a +13i at the end. All right, hopefully I'm not moving too fast, but I think this is ideal here. You have 5 plus 3i times the conjugate. Remember, we need the conjugate. Do not change the sign on the real part. I've said that many, many times. Don't change the real part, just change the imaginary part. And so we multiply going across. You can see that this becomes a +1. -I squared is actually +1. It doesn't just cancel. Okay, it doesn't go to 0. Anyways, we got 9 plus 1 is 10. These guys cancel out. And you've got 15 minus 5i stays that way. And you're going to go ahead and combine those. This is your final answer. Now, one thing that some textbooks do, I don't know if you've looked up the answers in the back of your book. I don't know if you can for topic reviews. But sometimes they will split the fraction up. Okay, they'll split the 2 between the two terms there. And this will be the final answer. It all depends. This is a little old-fashioned. But if you were to go look at an electrician's book, you'll see that they actually split them up. Okay, the real part will be its own fraction. The imaginary part will be its own fraction. That's just how they do it. All right, so next one, same thing, except now we got a conjugate with a binomial in the numerator. We're still going to multiply that by that, so we get these 4 things always change. These two actually change. These guys cancel out. And so you can kind of pause the video if you want to see maybe you made a mistake, maybe you got it all correct. But your final answer should be this guy right here, where 2 minus 6 should be -4. These become -7i. And then you should get a +4 plus 1 for 5. All right, that's 30. Okay, now 34. This next one is actually 35. 34, I'm going to go ahead and just put the book under the screen here. All right, we'll see what mistake they made. It's an error analysis here. Okay, so it looks like they multiplied these two. Okay, so 2 times 4, 2 times I, -3i times 4, -3i times I. Okay, so it looks like, all right, what'd they do? I don't see any errors, actually. The only error I see is that they just did not turn this into a +3 to combine. That's all. All right. So that's the only mistake. Okay. So moving forward, then we'll go to 35. Now 35 was a story problem involving complex numbers. Now that's usually you don't see a lot of story problems with this because no one has studied electricity yet. Usually. This right here, this is a formula of impedance, and looks like the voltage equals the current times the impedance. And so the E, the voltage, is this imaginary number, and it's the way that circuits work. It's really nice. That's why they use complex numbers in circuits. It's a very, very fast way to solve problems and change directions. The Z is the impedance, and you're going to, if you want the current, which is symbolized by I, then you actually have to solve for I. And so in order to get I by itself, you have to divide both sides by Z. And so this means then, since I have these two values, I can actually divide these two values here to get my current. And so that's the problem. The problem is figuring out that this is a division problem and then carrying it through. We have two values here, two terms, so the binomial. You'll be multiplying both the numerator and the denominator by the conjugate of the denominator. And we get this process here. This is pretty cut and dry. You'll notice that these two cancel out. These guys change their sign. We add them up, and this would be our usual final answer. We might reduce this fraction. I can say that you can divide everything by at least 4. Okay, and so if you looked in your textbook, though, your answer would actually they would split that 32 up between the two terms. They'd find out what that decimal is. They'd put that there. Find out what that decimal is, and put that there. All right. So if you got this, you're basically almost 100% correct. We would just kind of take that to its the most simplified fraction version, and here we can split it up. So your textbook writes this, and you might look it up. You might think that you got it wrong, but you didn't. It's all correct. All right. All right, and that is complex numbers.